Good morning, everyone. Welcome back. Now we will discuss a very important issue in statistics. We are having a roundtable to discuss the future of statistical education. This is indeed a very important topic to discuss. Nowadays, there is a lot of discussion about big data, about artificial intelligence, and all of these fields have a heavy component in statistics. So maybe we should adapt some of our programs. Maybe we should change something. This is what we are going to discuss here today. Today, I have the pleasure to have in this roundtable three very well-known national and international colleagues. I have the pleasure to introduce Denise, Nalini, and Marcus. It is a great pleasure for us to have them here to share their point of view and their experience on this topic. I will start by introducing all of them, and then they will have about 5 to 10 minutes, 12 minutes for a short introduction, and after that we will open the floor for questions. So the first colleague that we have in this roundtable is Denise Silva. Denise, she's a principal researcher of the National School of Statistical Sciences, the ENCE, from the Brazilian Institute of Geography and Statistics. She completed her PhD in statistics at the University of Southampton and has been working as a survey methodologist for more than 30 years, as well as a lecturer at graduate and undergraduate levels. Denise was the president between 2019 and 2021 of the International Association of Survey Statisticians. She is an elected member of the International Statistical Institute and an editor of the Statistical Journal of the IAOS and the International Statistical Review. Her main areas of interest are survey methods, official and public statistics, statistical modeling for social sciences, small area estimation, and time series analysis. Denise, it is a great pleasure for us to have you with us. I think I will introduce you, I will give you the word, and then I will introduce Nalin and so on. Okay, so now if you don't mind to share your slides.
Yes. I believe you're seeing my slides.
Yes, they are here. Perfect. The floor is yours, Denise. Thank you.
Thank you very much. First, I would like to thank the opportunity to take part in this roundtable. It's really an honor. The event is a successful event that has been in its third edition, and it's now a tradition in our statistical and data science community in Brazil. And I will share this roundtable with Lanini, Marcos, and Paulo, which is an honor for me. So because I believe that we will be talking or complementing each other, I will go for a focus on first talking about general statistical education, not exactly in a higher education, and then I will give one slide with some points about higher education. Because I'm dealing with official statistics and public statistics my whole life, I'm very fond of it, and I believe that it's a very important thing for society and democracy. So I will deal with this one of these topics. So the contours are what's going on in our society and in our world. You all know about this. It's data deluge and information explosion, the data revolution area, technological innovations that have been going on and on and on and never stops. The artificial intelligence race and all the ethical issues, related issues, We are in a changing society. We have complex relationships between social media and democracy. We see this in Brazil all the time and in other countries. And we do have this pandemic mode world that have been highlighting well-being inequalities. The well-being inequalities were always there, but the health inequalities and the digital divide have been were highlighted during this period. So I will start revising things with statistical and data literacy. Now, we do need to understand our quantitative world. In this time of the pandemic, this was a must. So everybody's saying that statistical literacy is a must, and we have been seeing the moving averages in our media all the time. So we have the role of data in a world of fact and fiction, and it's getting more and more and more important and relevant to the tango them. How can we improve the quality of public debate using statistics? Because we do have all these cases of people lying with data that are not well understood. And we have to challenge those who misuse statistics, and there is a lot of debate about misuse of statistics. And if you want to know more about it, there is the International Association of Official Statistics. They have blogs about it, and the International Statistical Institute in its website also have a lot of discussion about this. So we need capacity building for a data-driven society and attention to skills required to understand statistics about society. So in this sense, I will talk about statistical education for understanding statistics about society. And one of the things is civic statistics. And what we call civic statistics is statistics about all the contemporary social problems and also about economics. So we talk about poverty, we talk about demography, we talk about health, we talk about statistics, education and education statistics. And it is society is a multivariate phenomena, and we need to understand all this data. I quote here a paper that Professor Marcos Magalhães, that will be one of the next speakers in this session, is one of the authors, that has just been published about the COVID pandemic in Brazil and how the statistics education may contribute to unravel the reality behind the charts and the data. So we are all involved about data, tests, vaccines, vital statistics. So I have this more and more this impression that we cannot separate what we teach about statistical techniques from what we need to understand about our society that comes based on public statistics and other types of data. So there is also some comments that I would like to make about how do we teach statistics in undergraduate courses, or how do we use it? And I am included as an university lecturer in this group, and it's about changing the idea of an example with real data that in fact is different from as an example from a real problem, because real data can be water flows in Nile River in 1893. That's real data. But is it about a real problem? And that's the difference that we want to highlight. I want to highlight here. So I believe that we need to educate the youngest to informed citizenship. So as I said before, civic statistics and civic numeracy are important, and they are important to social justice advocacy. So people have to have their voice, and their voice now comes with evidence, and evidence comes from data. So that's one more reason that statistical education now needs to come with different literacies. Here, just to highlight that I'm not the only one talking about civic statistics, and these are projects that are from the International Association of Statistical Education, from the ISI family, and also the United Nations for engaging civic statistics. And there is a call for actions, and this is dated from 2018. So if you're talking about literacies for statistical education, I had this graph before. So someone that has watched another talk that I gave, I had this one. I had this graphic here. But I'm now adding other literacies that what I'm including: media literacy and algorithm literacy. And although statistical literacy is in this part, I want to highlight, and then I want to ask you to discuss this, that statistical education, it's important to include all these different literacies. And when I say literacies, I say literacy in all levels. So it's for school-age children, but it's also for our university students. Because if they only know the techniques and they don't know about information literacy or critical reasoning, we will be promoting new professionals with very narrow vision of the statistical capacity and our role in society. So what I want to advocate here is that we have to keep opening and widening our windows. So about the algorithm literacy, it's really serious, and I'm learning about this. This is a project. It's an UNESCO project with other partners, and there is a lot of that have already been done and developed. You see, educational guide. It's educational guides how to teach children, teenagers, adults to understand and reflect on algorithms. So to understand what the algorithms are, what are they impacting our lives, and how, if they can be biased or if they are affecting decisions or not. So algorithm is nothing new. You all know better than me. And I will tell you a short story. I don't have many slides left. When I was 14 years old, I was in school, and I was in a technical school. I was in a technical school for statistics. So the National School of Statistical Science had a technical course. That's what I did in college before university. From 14 years old to 14 and a half to almost 17. 17, I went to the university. So at that time, I had some classes about algorithms, and at that time it was about calculations and machines. The discipline was called like calculations, machines, and algorithms. So imagine in 79, 78, was a 14 years ago, having education in algorithm. I was one in not many, or not in my class. My class, there were a lot of women and things. What I'm saying is how many young people at that time, more than 30 years ago, would have algorithm training. Now what we are saying that if that in that case at that time was a rare thing, now we need to make it more broaden. We have to broaden this knowledge, because it may regulate people's life, and the life may be separated in opportunities for those who know about algorithms and for those who are ruled by them. And I've been reading about this. So some topics that are putting all this together, all this literacy, that I was thinking, well, perhaps we have to to take them in account from early age, but also considering them until we go to the university to revise our university degrees. And then here I'm listing some topics for undergraduate programs, and I keep saying statistical science because I love statistical science, but can be data science or any other degree that you may think or rename it. But this, note please that I'm not listing any other topics that are already, I'm not listing computing, perhaps not programming, not data visualization. I'm just listing some of the topics that I don't see them frequently in our higher degree courses altogether. So I'm listing here ethics, including information ethics, data ethics, and algorithm ethics. There are different things. Civic statistics, that I've been advocating for them. Introduction to contemporary social problems, that may include demography also, and then economics. Statistical reasoning, because statistical reasoning is different than exploratory data analysis. Sometimes I see people talking about graphics and data, but is it a statistical reasoning that we need to discuss? People have to think about statistical reasoning. And recently I gave a course for adults in the control area, procurement area of the government, and the statistical reasoning we were discussing about, and they were linking the statistics or exploratory data with their own problems. And then I list in red all data topics like data quality, information quality, data integration, including geospatial data, data editing and imputation. And when I say data integration, geospatial data, I'm not saying spatial statistics. I'm saying data integration with spatial data. Data editing and imputation, we have loads of data. They have errors. They have to be cleaned. They have to be evaluated. Data confidentiality and statistical disclosure control. Artificial intelligence related topics. I'm not an expert on these. People in this group that are promoting an event are much more knowledgeable about this. And then I come to problem solving, that are problems, as I said, instead of real data applications. I think that sometimes real data applications is not enough. Communication skills and report writing, and I also added here speech and debate. The idea that you learn how to advocate your ideas, how to listen to other ideas, how to debate in our ideas in a scientific and also in a civilized, difficult words for me in English, in a civilized, can I someone help me? Civil, I would say in Portuguese, numa maneira que é in a way that you are not fighting to each other, that you are in fact discussing with correct way of two people talking about opposite ideas. So just to finish, I would say, I will ask, can you pursue a holistic statistical education? Things that take into account a whole, not parts of technical and models and computing. Can you, will we manage to do this? And about civil statistics and also data science and statistical modeling, I want to highlight here that we have a regional hub for big data in Brazil from the UN Big Data. It's a UN activity, and the coordination of the UNA, the regional hub in Brazil is in the Central Statistical Office, IBGE, and the National School of Statistical Science. And I want to show you about the hub and the UN Youth Hackathon, calling you to make your groups, to make your teams and participate. because it's to create solutions on world's toughest problems using data, and UN's, and also to fast track progress towards UN Sustainable Development Goals. The deadline for registration is November 6th, and it's open for group of students, 3 to 5 students, and or groups of 3 to 5 young professionals up to 32 years old. So the groups cannot mix, a professional groups or mix. So please have a look and join this hackathon. So I finish here with just the reference.
Thank you very much, Denise. Thank you. I will now pass the word to Nalini. Nalini, I will first introduce her. Nalini is a professor in the Department of Statistics at the University of Connecticut. Her current research interests include time series and time to event analysis, Bayesian dynamic modeling, signal processing, and predictive inference. Her primary interdisciplinary research involves problems in finance, marketing, and transportation engineering. She has an undergraduate degree in statistics from the Presidency College in India. She holds a PhD in statistics and operations research from the Stern School of Business at the New York University. At the moment, she has over 100 publications. She is co-authored of a textbook called A First Course on Linear Model Theory, which is in its second edition. And she's co-editor of the Handbook of Discrete Value Time Series. Both of those books have been published by Chapman et al. She's a fellow of the American Statistical Association, an elect member of the International Statistical Institute, and an elect member of the City Academy of Science and Engineering. Nalini, she served as president of the International Society for Business and Industrial Statistics between 2017 and 2019, and as the vice president for education outreach in the New England Statistical Society between 2017 and 2020. She has served as a theory and methods editor for the scientific journal Applied Stochastic Models in Business and Industry, and as an associate editor for the American Statistician. Currently, she is co-editor-in-chief of the International Statistical Review and an associate editor for the Journal of Forecasting of the Chilean Journal of Statistics and the Annals of Science and Technology. Nalini, it is a great pleasure and honor to have you here. Thank you for your time. I miss to meet you in person. We had some good time in some conferences. I really miss to meet you in person, but I hope that will change very soon. Nalini, if you want to share something in your screen, please feel free to do so.
Thank you, Paulo. Can you see my screen?
Yes, we can.
All right. I do not have slides prepared. I thought I would just talk in an impromptu way about how I have seen statistics teaching evolve over the 30 plus years that I have been a faculty member in the University of Connecticut. This is a research institution in the northeastern part of the country. And I think the evolution that I have been seeing in statistics education over the past few years, between 5 to 10 years, is pretty typical, I would say, of what has been happening not only in universities around the country, the United States, but I'm also seeing the same kind of trend happening in countries around the world. Now, I'm going to be focusing on higher education. I know Denise addressed a more general form of education. Let me talk about statistics coursework and statistics education and teaching at the undergraduate course level and the graduate course level. Now, I would say that for most students that are coming in as majors in this field, one of the important questions is how well are they prepared for the workforce once they have completed a degree in statistics. So by workforce, I mean industry, government or non-profit agencies, as well as academia, training for those things, right? And I will run through the list of courses in a few minutes, and you will see how we have transitioned slowly, primarily in reaction to what the workforce training is asking for in 2021, as opposed to, let us say, the 1980s or the 1990s, and how we want statistics to play an integral role in this evolution of data science and this burst of data science into our psyche and into our life. So let me just run through and show you what is happening, right? So this course, Introduction to Applied Statistics, is an old course. So I'm just going to run through. I won't run through all of them, but you guys can see how we are changing some of the courses, and in how many of the courses at the graduate level, you see the word data science. So this course, Computing for Statistical Data Science, is a new course. And it's very easy to see how, like Denise was saying, algorithms, right? So now we talk this language. We talk about introducing things like data structure, data programming, visualization, simulation, resampling, right? Distributed computing, project management tools. Out of all this, in few years ago, we would have probably seen visualization. We all do histograms and those things. Simulation, yes, we simulate from distributions like binomial or normal. Resampling, yes, after Efron introduced the bootstrap, we all try to teach bootstrapping or jackknifing in our statistics courses. But you also notice how things like focus on data structure, programming, project management, distributed computing are all a nod by statisticians in our courses to data science and workforce needs. So I will just run through this, and I will let you guys decide how many of the courses in our graduate program you think have possibly changed with the times. Even mathematical statistics. We teach mathematical statistics routinely as a year-long course, but now we have even condensed it to a one-semester course in a nod to data science. So you can go to our graduate program and look at this. Let me also run you through the undergraduate coursework, and you will see the same kind of thing happening. We also have a nod to different domains. So we now have courses that are specifically designed towards health professions, because my department has one focus on biostatistics. The interesting thing is that we have not done away with the rigorous courses like probability or mathematical statistics or inference. No. We have grown the data science courses alongside the rigorous inference courses. So my department has decided a while ago that we will go hand in hand, and we will teach the new types of courses in addition to the other courses that we have already been teaching. So this should give you an idea of how many of us in our universities are looking at the future of statistics education. We do not want to compromise on the rigor that we give our students to train them adequately for the workforce. We also want to integrate the new ideas into our courses. And this seems to be the way the teaching of statistics is evolving at UConn and in many, many universities in the US, as I said. I have friends throughout the world. And I know, for instance, in many places, right, I've spoken to friends in different parts of the world, and they're all trying to do the same thing. They're trying to integrate data science into their curriculum. And one way in which I think I would like to do this, and I agree with Denise, is that we need a handshake with computer science. I know there is a lot of discussion on who invented clustering first or who invented this first. Yes, it may be nice to get credit as a group, but what is more important is to a handshake and work together so that the students who are getting educated get the best of both worlds. For instance, we are starting a master's in data science in our university next year, and that's what we are doing. We are integrating statistics and computer science courses. We are bringing in domain knowledge. And like Denise pointed out, ethics is a very, very strong thing. And there is a special course on ethics. And I think many, many universities are trying to do that as well. So in a nutshell, what is it that I would like to think of as educating in the future a strong cohort of statisticians who populate the workforce is to not sacrifice the rigor, that is the theory and methods of statistics, to integrate computing in a very, very strong and meaningful way into the coursework, to integrate an interdisciplinary context through domain integration, talking to different people in different domains, teaching them communication. Denise mentioned this, communicating the project, communicating the results to outsiders is very, very important. And in general, training our students to be responsible promoters of statistics around the world. Thank you.
Thank you very much, Nalini. Yes, I think that will give a lot of material for discussion in a few moments. I will now pass the word to Marcus. Marcus, it is a great pleasure to have you here. Unfortunately, we don't have it in person. I will start to introduce Marcus. Marcus is well known in Brazil and internationally. Marcus Magalhães is professor at the Department of Statistics at the Institute of Mathematics and Statistics of the University of São Paulo. He obtained his BSc and master degrees in statistics from the University of São Paulo and a PhD in industrial engineering and operational research from the Virginia Polytechnic Institute and State University in the US. His main areas of research are applied probability and statistical education. Marcus has published 4 textbooks with the book entitled Notions of Probability and Statistics already in its 7th edition. And this is a major reference for all the BSc students in Brazil. So Marcus, it is a great honor and pleasure to have you here with us. You do a lot of work and a lot of outreach in education, in statistical education. So when we thought about this roundtable, you were of course one of the main persons that we thought of inviting, and we are very pleased that you accept our invitation. Now, please, the floor is yours.
Thanks, Paulo, for the invitation. After my mother, I think you are one of the persons that say about me with more friendly. Let's put my slides here.
Everything that I said was completely true.
Okay, no, I just want to say that I thank you and thank for your words. Like we thank our mothers when they are gentle. And okay, well, the title of my talk is "It's Better to Believe a Simple Idea Can Be Successful." I'm gonna point out another aspect and in some sense complement what the previous speakers talk. Okay. Well, first a warning. This talk is not about early treatment with chloroquine and erythromycin. We try only use scientifically proven arguments. A brief summary, I'm gonna say something about statistics everywhere, statistics teaching, and some comments for the future. Well, statistics everywhere. Numbers is our daily routine as a statistician or students in this field. We get used to lack of information in some areas and also with large databases. There are even Congress to discuss this subject, like the present one. However, for the general public, numbers can be frightening and intimidate. Unfortunately, for many people, simple calculations are only performed with the help of a calculator. Basic schools have a central role to change this situation. This, I think, is a key point if you want a world that can understand statistics, that can understand numbers, cannot be afraid of numbers. You need to work hard to the basic school, provide some information in good quality. In recent months, we have had an important change. Statistics, in many of these terms, have become popular. Unfortunately, for a terrible reason, the COVID-19 pandemic. The so-called COVID-19 numbers appear frequently on TV and other media. Are mentioned, as mentioned by Denise, some terms such as immunization rate, vaccine efficiency, number of deaths, quarantine period, moving average, and transmission windows appears frequently. This way, we have new opportunities to use all these terms to illustrate our classes and maybe promote some changes. Let me say something about the statistics teaching, and I will concentrate in the Brazilian situation. In basic schools, statistics contents are part of mathematics disciplines. In fact, this happens also in most parts of the world. BNCC, the Common National Curriculum Base, it's a recent official document, indicates teaching statistics in all years of basic education, and then describe topics that are supposed to be discussed in all series of the elementary, middle, and high schools. At the undergraduate level, mainly in public universities, statistics departments teach statistics to several careers. This is common in Brazil, at least. Statistics department teaches statistics for economics, for psychology, for social sciences, for biology, etc., health courses. And in general, this is responsibility of statistics departments. Regarding to mathematics discipline teachers in middle and high schools, in general, they have a teaching degree in mathematics. This means we call in Portuguese licenciatura em matemática. During graduation, they learn statistics in 1 or 2 basic courses. This is a general rule. In some universities, maybe you have just one, mainly in the private schools, private universities. But in general, 2 courses is what we have. These courses should enable prospective teachers to teach statistics in their classes. To a large extent, this is not happening today. They feel insecure about teaching statistics. In my recent research in contact with middle and high school teachers, in general, the statistics topics is not covered, or when they are covered, they are covered just in a technical way of formulas and expressions, in fact, in a deterministic way. And they not explore the important characteristic of statistics, that is its variability. The variability is the sense of statistics. Basic statistics at universities. In general, teachers have a PhD degree in statistics. And teachers are, generally speaking, well prepared with respect or concerning the contents. But sometimes they are not using adequate teaching procedures, or not care too much about the way how the subjects are discussed in class. Also, great pressure for publications is common, leading teachers to devote less time to teaching tasks. Mainly, as I said, in public universities, this pressure for publication leads a kind of disciplines or teaching tasks be something like waste of time or some deviation of the main activities that this teacher supposed to do. For the future, hopefully near future, improve research in statistical education, I think it's one important thing in Brazil, in all over the world too, of course. Some journals that present results of research, some are international journals, and the other Brazilian journals that have this kind of discussion. Some congress. I think the main congress, it's IAOS, International Conference on Teaching Statistics, and it's important to say that the next one will be close to us, in Argentina, in Rosario, in Argentina, in September 22. And then will be also an opportunity to hopefully be a presential meeting. There is other congresses that discuss statistical education. Some of them are listed here. Another point important in the future, I think, it's improve basic statistical courses at university. There is a GAZE report recommendation that is a publication of American Statistician Association that gives 6 recommendations for college basic statistical courses. First one is teach statistical think. It means the priority must be ideas and not technical solutions or formulas or just expressions. Second, connect with this first one, it's focus on conceptual understanding. This is important for the student have an idea, the central idea of subjects presented. Third, integrate real data with a context and a purpose. In this sense, it's important to mention that Denise's point of view about civic statistics is one important point to be highlighted in our basic courses. Fourth, foster active learning. Students must participate of the course. In our field education, we can looking for the students in class. Now then, sounds or seems they are participating, understand. But you must be able to go there and use the brain of the student. I used to say that we need to invite the brain of our students to come to class, not just the students. In fact, the brain is part of the students, of course. 50 suggestion of the GAZE report, the use of technology to explore concepts and analyze data. And sixth, use assessments to improve and evaluate student learning. It's important that all the assessments stay connect with the objective of the course in the sense that can be a help to development of students. There are many paths in the future, and we are building our path, and you can go in different directions. However, I would like to suggest a starting point with a simple idea, improving discussion on the basic disciplines of statistics at university departments. Young professors of these basic courses need to be involved, in some sense convinced, in the task of offering quality courses. which is one of their most important tasks at the university. Obviously, it's also necessary to convince the administrators, but sometimes this is much more difficult. In general, these reflections about courses can give you an opportunity to discuss ideas that are present in the area of statistics education. This discussion can promote change and, in general, improve the quality of the disciplines. Also, as reported in several works in the area, the best quality of these courses has important consequences. In particular, in basic education, teachers better prepared provide an important multiplier effect that contributes to greater statistical literacy in society. It sounds so simple, but it's not easy. How about trying? In this, you could be a challenging in most universities or in most departments in Brazil, yeah, maybe in other countries too. Thank you for your attention.
Thank you very much, Mark. I will now bring Nalini and Denise, and I would like to thank the three of you for sharing some of your initial thoughts. I think now we are ready to open for floor discussion. Before that, I don't know if any of you would like to make any comment on what the others said. If you'd like to do so, we can do it first. Otherwise, we can go right away to the discussion.
Okay. I don't have that. I think the other presentation was very, very good, giving me new ideas to think about the things.
So I will start to put here some of the comments or questions that were written on YouTube. So Vinod Kumar, he wrote that the statistics is not a popular graduate program. Would it be intelligence or socio-cultural factor responsible for not studying the course? I don't know if you have any comment on that. About it is more. Yes, please, Denise.
Well, I would say I don't know if I'd be commenting on what Vinod would be interested, but I think there is multiple cases or multiple dimensions, because if you see in our country, in Brazil, first, the statistics were not popular because they were not well rated as a profession. So those, you use a young guy or a young lady will say, "Oh, I'll do statistics." The dad and mom will say, "Do engineering, do economics, don't do statistics." No one knows who statistics is. So that's a cultural thing. I don't see it's like a social, so it's a socio-economic fact. So it end up, at least in our school, for many years, we didn't get the students with higher level of income. We got the opposite. We got students with from lower income families, meaning that they are interested in statistics and they see as a entrance to the labor market. Now, more and more and more, what I'm seeing in our courses, in our undergraduate courses at least, it's an imbalance of gender. So statistics have become popular. So there are many men attending the courses. And also, I'm also seeing students with higher income levels in our courses that we didn't see. And the other thing that I believe that also matters is about how maths is taught in our country, at least in our country, because it's something that there is still, it's not that how the maths is taught, let me correct. It's like the discourse that maths is difficult and then stats is difficult, and it comes from the whole education of the young people, and then they end up not choosing statistical course. So that's why I was talking about how we will do statistical education for the young people, that they will feel it's an interesting subject for the future.
Yes, thank you, Denise. I think that also what Nalini was showing about how they adapt the courses on including the word and the term data science and adapting the contents. I think that changes a lot for sure. Please, Nalini.
I think Vinod, I don't know if he's currently in India, but in the US, for example, statistics is a hugely thriving graduate program. It has a lot of clout, and we get tremendous number of applications in the universities to study statistics, and we are only able to admit a small proportion of the applicants. That goes to my point, and some of the stuff that ISI, Denise knows, has been doing is trying to build capacity building all around the world. And I myself have provided programs through ISBIS in India, Nepal, Sri Lanka, and stuff like that. Maybe what we need to do is statistics grew up in India, right? Statistics thrived under Mahalanobis and Rao in India, but somehow suddenly there has been this lack of popularity. It could be the adapting that, Paolo, you're talking about, that you need to make it attractive, right? So that the minute you get a degree in that field, somebody is approaching you for a job, paying you a high salary, and then that motivates these young kids to go take that course, maybe.
Yes, please.
Can I add a comment? I agree completely with Paulo, and what Nalini shows us is that the programs in the United States had adapted before us, so they are more attractive, and this has a direct impact also, as what I see in my school, is the number of people who manage to graduate. So we do have 120 students per year, but the graduation rate is very low comparing with the. That's meaning that we still have we never think, or we think but we don't do enough to improve our courses in the way that we make more people able to graduate as statisticians in my course, because all who graduated had jobs directly, but the number of those who graduate are still lower than, at least less than 60% than those who enroll. And this is one of our problems that we need to solve.
A little comment here, Paulo. I think it's a conjunction of situations. At an undergraduate level, most students that complete the high school don't know about the existence of a statistical career. They don't have any idea there is a possibility to do a bachelor's in statistics. Then this means the number of students that try to come is much less than other careers. On the other hand, when you look for a graduate programs in statistics, they receive candidates But there is another point important. Because the career of statistics is relatively well paid in the market, the students finish their course and go to the job, to go to work. And sometimes it's not easy to convince the good students to continue to a master or a PhD program. Another point that just happened these days in Brazil, the cut of the support for fellowships to the programs, it's completely cut in Brazil right now by the federal government. So this has impact of the number of possible candidates to a graduate program in statistics, master's and PhD.
Yes, this is very true. I would add something of what Mark said. It's not just the students that finish higher education, secondary education, that don't know about the BSc in statistics. If I go to my university and do a sample of students, I think most of them would not know that there is a BSc in statistics there. So, and I'm talking about students from all universities, of course, from all areas. So this is indeed something that we should change somehow. Moving forward, I have here a compliment from Christian from Nalini's book. He loves it, and also Radonal says it is a beautiful book.
Thank you.
In the sequence, there is a question more direct to Nalini from Christian. He says that do you think it's still necessary to learn programming languages such as C++, Pascal, or Fortran, or is better to start with R or Python? Because I actually realized when you were showing your courses that you had a course on R and SAS. I didn't see the word Python there, so I will add to that question of Christian.
The reason we do not have Python explicitly is because that seems to be something that the computer science people teach, so we don't want to turf war. Yes, data science courses, the students will be open to doing things in R or Python, and I mean, I'm very proud that I'm learning Python now and I'm doing well. But to answer Christian's question, personally, this is for the PhD point of view. For the master's point of view, I think if you learn R or Python, that might be sufficient, right? But I seriously think that if you're going to be coding out there in the real world, knowing C++, let's say, or C or Fortran. I'm an old person that knows Fortran, but I know all the kids learn C++ these days. It is good because you know how in the background these packages use C, right, and C++, and that's fast. That gives you the speed. So my answer is yes. If I have a PhD student, they learn C++ or Fortran alongside R and Python, which is more or less like a wrapper in my mind many times if you're doing very serious programming.
Yes, thanks, Nalini. Now I will show a question from Zita Albacea. I thank her for the question. This is a very important question, and there could be a lot of discussion about that. The question is: do you think that in the future data science will replace statistical science? Who wants to start? There's a lot of talk about that for sure.
Well, let me start here. See, what happened with the names? The names become popular at some moment, but when you look the explanation of the name means, the titles, you see very many words or sentences that are common to the old names. So maybe data science or can be a discussion that in some sense substitute statistical science. But I don't think so. I think data will be all the time an important subject of the discussion with statistics, but statistics maybe has a large, let's say, look. I don't know. I'm not sure. But in fact, this kind of dispute maybe would be good for marketing in the private schools to search for students and maybe to attract students. But I think in a sense, the data science is still discussing important issues that happen in the same way in statistical science.
Thanks, Max. Do you want to say something on that, Denise, Nalini?
Yeah, I believe that they will become closer and closer, and in the sense that it's not talking about the names, but if you see what is listed as data science, and what we are seeing is that statistical science courses, at least higher degree courses, but undergraduate courses, are moving towards incorporating, like Nalini showed, a lot of things that are needed for data science. And I listed some that I believe that we have to include for data science. And what I believe we will have in the future, we have like a mix of them. There will be courses that will be saying just data science, and will be less components of statistical knowledge or statistical, I would say, pillars. And then they will have more courses with called statistical science, but with much more components of data science. So I believe that both of names will survive, but each of the pathways will incorporate things of each other in a sense. And that's why many of the courses now are being open with statistical and data sciences. They are together because the pillars are needed, and there is also nothing to incorporate. So I don't see so much of this duality at the moment, because I think we are learning that we have to progress in data science within the statistical science.
Nalini, do you want to comment on that?
Just a very short sentence. I strongly believe that data science is an equal partnership integration, if you will, of computer science and statistics. So rather than a diluted outcome, I am thinking statistical science still stays strong, but as a very strong component of data science, integrated nicely with CS. And I think that makes for an overall better science as an outcome.
Yes, indeed. I also think in that direction, that the term data science is a nice wrapper to put together computer sciences, statistics, mathematics, and some domain expertise. Of course, if you are dealing with biological data, I don't have enough knowledge for that, so we need a biologist. So I think it is. I don't think it will replace. There is no way to replace that. If you think on one of the most used algorithms for classification in machine learning is the logistic regression. Yeah. So you cannot really replace. You can change a little bit the names, but the background is still there. I have, please.
Paulo, excuse me. This may remember me. I agree with all the comments and Denise and Nalini. I remember. See, there is a book with the authors are Busabi e Moretin, Wilton Bussabi Moretin, e Pedro Moretin. Moretin is working time series, maybe Nalini heard about him, but in Bussabi it's dead now. But they have a book. It's a book at that time with tables of the normal distribution, chi-square distribution, etc., etc. Can you imagine have a book now with the names of the table? It's an evolution. It's in some sense the data that at that time it's hard to compute and justify a book with tables. Now, no makes sense, right? But it's just an example that what you said.
It is the evolution, right? Some things do not make sense anymore.
Yeah.
We have here plenty of questions. I will put one more. I'm going to prioritize the questions from people that were not answered. Okay. So the next one is from Isabel Latas. She says that there is an urgent need to change the approach and topics of the undergraduate courses that we teach. Testing hypothesis of difference in the mean is not interesting or modern. Which topics should we cover? Does any one of you would like to make any comment on that?
Well, I can start again. I'm not sure if you agree that different of mean cannot be interesting. For sure, you must discuss the public, the students, what the students know, what they need to know. And I used to say that the best thing that you can teach is that student can be have some kind of confidence that can be learned. Things you must concentrate at main ideas in basic courses. In this sense, difference of means can be one of the topics that maybe it's important to illustrate hypothesis testings or confidence intervals, etc. But the main thing that you must care is the possibility to a student have kind of support that can think about things in the future, issues, ways, or choose topics that they need to learn, and they have a kind of support that can go there in the future and do by themselves. I think the point in these undergraduate courses that we try most of the times in general, obvious there is differences, but sometimes you want to produce receipts to finish a kind of exercise. Then exists type 1 exercise, type 2 exercise, type 3 exercise, and the student go there and just learn type 1, type 2, type 3. They don't have the main ideas or the concepts that allow them in the future to solve problems, new problems, different problems. I think this is my look for these courses.
Please, Nalini.
If you're really thinking of making it interesting and bringing it to the real life, I would say bring in the notion of multiple comparisons, the multiplicity, and then you can link it to the p-value controversy that is raging. And the American statisticians, ASA is putting out so many things about it. The other thing you can do is, and we do that, not maybe in the basic course, but maybe as a project or something. What if you don't have normality and you cannot go to the t-test immediately? What if the underlying population is something else? Can you bring in the notion of a Monte Carlo test, right? So instead of having this test statistic, which has this exact sampling distribution, can we do something that is more data-based? The bootstrap based resampling idea. So those are little things that one can do even in the context of testing to means, that takes you away from the very classical and brings you more, right? And we also start talking about effect sizes these days as part of this p-value controversy. So one nice way I think would be to integrate what the current statistics community is talking about into even the undergraduate level, so that the kids know that such things are being talked about. And it's not just the Neyman Pearson that we are still teaching them. That's just one thought.
Yes, thank you. Please, Denise.
Yeah, I would say that it's not exactly what to teach and how to teach. It's very important. So I noticed that it's much more easy for people to understand the notion of confidence intervals. And then they come from the notion of confidence intervals before going to the statistical test. And the idea is that they are for solving problems that has to be done. So I wouldn't do anymore. I wouldn't do a course that we have showing every test with every distribution in the classical way. It's not working like that. People have to understand that they need a statistical test, and why do they need? And they will also use it in statistical modeling, because that's how we help us decide if a model is it's good or not, or if such effect will be in the model or not. So you start telling the ideas how they will be important. I know I have noticed that people are anxious about the future. So if they are learning something now, they want to know how they will use and how it will be important there. So I start talking sometimes about statistical tests and saying, we are starting with it now, but really use for learning. Do you want to learn at statistical models? And then you see the models for all the things that is happening in society? Yes, I do. So you will need statistical tests there as well. So you have to enroll in these different ways and not teach all the details. You have to teach small, because all the details people won't use directly. And then this is something that we used to do before. You have to teach all the details, otherwise they won't know or they won't learn. And that's not like that anymore. So that's a change of way of doing things as well.
Thank you. The next comment is from Dr. Mutija. Dr. Mutija has been with us all the conference, was here every day, all day yesterday, although in Indonesia there are 10 hours more than here. So that is impressive. The question, I think, has already been answered in some way from the previous comments, like to try to adapt to the course, to include some databases, the data analysis, some data. I think that's more or less, I think you already answered that. I have here a comment from Rosaria. It is great to see Rosaria here. She says it is a great roundtable, similar from Olaide.
Can I add a comment about together with examples that came to my mind?
Sure.
I learned also by teaching that it's not only the examples, it's the stories. Sometimes you have the example, but we don't have an interesting story. So if you go to the magazines like the Significance or Chance, and you go to the ISI like Statisticians in the News and things. So now my motivating examples are not examples anymore, are the full stories. So I have started a course once in my undergraduate that where we still have them printed, and was I have a pile of significance, and then I distributed in the classroom and said, find a story. You don't need to understand the data or the technique. Find a story that you like. And then the person will find a story and they said, so how this is solved? Oh, this is statistics technique. So you will get this in the third semester. You'll get this in the course. So I think that for the statistical test, I'm doing this as well and asking people to find stories that is different from examples. And then we'll help people to talk about how this was used to solve and to tell a story. That's something that I wanted to tell you because I have experience.
Yes, thank you. I have here also comment from this is related with that comparison between whether data science will replace statistics. Pedro says that data science is not likely to replace statistical science. They will likely coexist, and this is reinforced by Olawale that agrees that they will exist similarly. Please, Nalini.
Just a note to Pedro, he doesn't dare say anything different when his wife said that same statement, right?
Exactly. I have here a comment or a question by Chandra. He says, I personally think that the core statisticians are lacking in the real world in comparison to data scientists, computer programs, etc. He's asking if there is any comment on this. I think what he means is that many times the statisticians are more worried about assumptions and all of this, while data scientists are more pragmatic. So I don't know if you have any thoughts on this.
I think one important thing to be taken into account is the time of changes. In some universities, it's quite difficult you be fast in the changes. You have a kind of bureaucracy to attend. There is sometimes some official regulations that you must attend, and then it's difficult. You change fast. But as I said, if you start discussing these courses, I point out about basic courses, but it's of course extended to other courses, then you promote the possibilities to even keeping, let's say, the label in some direction. We can put the contents, new contents, and new topics, as mentioned by Nalini, that helps just to have a better communication with the students. Because we need to remember that, at least in Brazil, the students are coming to the university in worst situation referred to mathematics background than we have a few years ago. They are more competent, for sure, in technical stuff like using technology, cellular, etc. But most of them, in some sense, the mathematical formalism, they are losing in the way. And that is a problem because most of the current professors at the university requires for these students a mathematics rigor that it's hard to get. And then is the necessary discussion that can, let's say, combine in a way that you can put the students in in a, let's say, psychology position, they can be successful. Because what you don't like, what you cannot understand, you cannot be successful, with what you fail every time that you try. You go to the middle term or finals term, then you just get zeros and ones, then this is what happened in most disciplines of calculus, algebra, etc. And then you need to discuss this. How will you solve this problem? And then in statistics, in some sense, stay in the package that is difficult to pass in disciplines, then is difficult to understand, etc. And then we need, in some sense, improve the discussion with the mostly young professors in the university, at the university.
Would you like to add something about this comment from Chandra, Nalini, and Denise?
Paolo, I sent you something. I don't know if you got it, but I have something here that Vijay sent me. If you don't have it, I can share. And I think this is very much to this questioner's point. Am I still sharing?
Yes, I can put it on. Oh, please. Yes, I didn't see it here. If you can share again your screen, I can put it on the screen.
I'm not able to, hold on, let me see if I can share.
Yes, now we can see your screen.
You can see my screen?
Yes.
Hold on, I had it, but I don't know, not able to show. Anyway, okay, here it is. Let me see. Can everybody see this?
We can.
So,
oh, yes.
Please take a look at this.
Yes, I actually did see this picture a couple of days ago.
Yep. This is something Vijay said. It speaks to the point that this person is asking.
Yes, so maybe it's better for us to be careful and to do things.
Well, we can all the time change the labels.
Yes, indeed. So I don't know if you would like to say something extra, Denise, or if any of you. I think we are 2 minutes to finish. I think we can finish on time. So for those questions that were not answered, I was prioritizing people that did not have any question answered before. Those people that want to discuss something in the book of abstracts, you have the emails from Marcus, Denise, and Nalini. Please feel free to contact them. So we are about to close. I don't know if Marcus, Denise, or Nalini would like to add some extra thoughts to this roundtable to close.
Lovely session. You're a great guy, Paulo. And thanks, Denise and Marco. This was fun.
I would say that the same that Nalini, and just saying that this is a perfect example on how we should keep learning, because we learn from each other today and learn from the audience. So yes, that was a great opportunity, and thank you for teaching me and make me thinking about how can I improve. And all the best. Thank you for the honor.
Thank you for the opportunity. And see, in a world that not have a kind of communication in a civilized way, there is no hope. What we had here was a discussion. I learned a lot from the contribution of Denise and Nalini. I really like very much participate in this round table. Thanks again to Paulo for the invitation, and let's discuss, let's talk. And the names of data science, statistical science, or computer statistical science, it's a part of the discussion. It's important to keep talking. Thank you.
Thank you very much. It was really a great pleasure. I think our attendees enjoyed a lot. We had always more than 50 people online. Now in the end we have 53, so we had a lot of people coming and going. So it was really a very nice discussion. I think we can even share this discussion with the Department of Statistics and Statisticians, so that to see if some minds adapt to the current situation and not to be kept in time. So thank you, Marcus, thank you, Denise, thank you, Nalini. It was really an honor and a great pleasure to have you here with us. Thank you very much.
Thanks. Thank you.